So today's video is going to be slightly shorter. What I'm going to do is show you what the Laplace transform of a pretty basic function is. The function is the Laplace transform of just 1, the constant function 1. And to do this one, what I'm going to do is just look at the definition of the Laplace transform, which I briefly showed in the previous video, but it's here again on the screen. And just write down the integral over here. So the Laplace transform of 1 is my f of t over here, is going to be e to the negative st times 1 dt. That's just, I mean, the 1 doesn't really do anything over here, so it's just e to the negative st dt. And if I evaluate the antiderivative of e to the negative st, what I get is e to the negative st divided by negative s. So I'm just going to put divided by s, put a negative sign out front over here, and then I plug in t equals infinity, and I plug in t equals 0. Those are my limits over here. And what happens at t equals infinity, where if I just quickly sketch the graph of e to the x, it looks something like that. So as t tends towards infinity over here, what happens is you have a negative sign in front. So as t actually tends towards negative infinity, this function tends towards 0. So finally what I'm going to get is 0 minus, and as t goes to 0, well, when t is 0, you just get e to the 0 divided by s, and there's negative in front. So e to the 0 is just 1, the negative signs cancel out, and finally what I get is 1 over s, which is interesting because initially all I did was plug in a number and out I got a function of s. So in general, what you're usually going to end up getting is the Laplace transform of some function of time is going to give you some function of this variable s, which we'll probably get around to talking about in later videos.